Let's look at algebra vectors. Under this we can look at addition and the subtraction of vectors. So we need to know what happens when you are having vectors and you are supposed to add them together. How do you handle it? What about when you are subtracting? How do you handle them? The statement here is saying that when adding vectors, we sum up the corresponding components together. And so is the case with the subtraction. So this means that you just get the i's together and the j's together. If they are k's, you also get them together, and voila, you are there to go, you are ready to go. So we shall have that illustration with this example, that given that a is equal to 3i plus 2j and b equal to 5i minus 6j, find the resultant of the vectors. Now what you need to know is that the resultant of vectors can be got by the vector sum of the two vectors. So by adding the vectors, the result you get by adding two vectors is actually a resultant vector. So that means that what you are supposed to get here, what you are supposed to do is to get a plus b, which is equal to 3i plus 2j. Then we add on b, which is 5i minus 6j. And look at the i's. We have 3 in the for a and 5 for b. That is for I. Then in the j we have 2 for a, and then this one is a minus 6 for b. That is what we have for j. So this is 8i minus 4j. That's what we get when we work out that. So this one is the resultant, that is the resultant vector there. The second example is also asking for, it is also asking for the resultant. Find the resultant of the vectors. So here we have I, j, and k. So still we have a plus b. We sum up those two vectors. 2i plus 3j minus 2k, then plus b, which is now I minus 4j plus k, where we shall have in the i's we have 2 plus 1, that is for I. For j we have 3 minus 4, that is for j. Then for k we have negative 2 plus this is also, it is 1, that is for the case of k. And so I have 3i plus negative 1j plus another negative 1 in the k. So I can just write this one as 3i minus j minus k, and that is what I have. I'm reading these things as I, j, k, but I'm not writing them as this. I'm not writing them like that. You should also do the same. It is I, j, k, because they are denoting unit vectors, not like that, but like that. I, j, k. They are denoting unit vectors, so we shall have that curve there. The curve should be included on the top of that, on the top of the I, the j, and the k. We can move on to example 3. Given the vectors have a 2i minus j plus 4k, b is 4i plus 3j plus 2k, and c is 7i minus 6k. That's saying find, Roman 1 is saying a plus b. Roman 1, vector a plus b. Here we shall have 2i minus j plus 4k. We are adding it to b, which is 4i plus 3j plus 2k. And what we have as the final answer here, I'm just going to write the final answer. It is 2, the i's, 2 plus 4. So that is 6i. Then j, -1 plus 3. So that is plus 2j. When it comes to k, we have 4k plus 2k. So this one is another 6, but this time in the k. That is what we have as A plus B. Then Roman 2 is asking for B plus C. If you are to get B plus C, you shall have B, which is 4i plus 3j plus 2k. That's it. And we are adding it to C, 7i minus 6k. And still I'm going to write just the final answer. 6, look at the i's. You have 4 and 7. That one is 11i. Then you come to j. There is 3j and there is no j here. So there is no j. So you have a 3 plus a 0. So this one is plus 3j. There is no j in C. Then we have 2k. And yeah, there is a k there. So you have 2k plus -6, which gets us a minus 4k. That is what we have as part B. Part C, Roman 3, wants us to get 4a minus c. So we shall have 4 times a. First of all, this is 2i minus j plus 4k, and I subtract c, which is the c is, where is it, 7i minus 6k. I can try to work out this to 8i minus 4j plus 16k. Then I subtract 7i minus 6k. And what you have finally here, you have 8i minus 7i. 8i minus 7i. That gets us I. When it comes to j, we have negative 4, that is for j, and there is no j there. So -4 minus 0. So for j, we have just 4j. When it comes to 16, oh no, sorry. When it comes to k, we have 16, this one, minus, this one is this. 16 minus -6. And this one will get us a positive 22. So this is plus 22k. That is what we have there. That is 4a minus c. The other one is now Roman 4 is asking for b minus c, and b is the vector 4i plus 3j plus 2k minus c, which is the vector 7i minus 6. This one is 6k. 7i minus 6k. So what we have here, i's, get the i's. You get the 4i minus 7i. And you are going to have, this is 4i minus 7i. That one is -3i. Then you have 3j minus c. There is nothing to subtract there. So I have plus 3j. Then when it comes to k, we have 2k minus, this is negative 6k. So this is plus 8k. That is what we have for b minus c as a vector, b minus c. Yeah, you can have to look at that. That's how we can go about that. You try out this, try to obtain b. This one is not showing. You try b minus a, and then try 6a plus 2b minus 5c. Try out those ones and for your practice and see what you are going to get. Let us look at some resolving a vector by playing with that magnitude, making an angle theta with the x-axis. Let us just focus on this diagram here and see what we can do when you want to resolve. If a vector is running from a point O to a point P, that vector has a horizontal and a vertical component, and the vertical component and the horizontal component, both of them can be got by looking at by using trigonometry. This side I can call this x, and I call that y, so that when I get the value of y, then this y is the component of p of the vector OP along with the vertical, and the x is the component along with the horizontal. If I use trigonometry, I see that cosine of theta is equal to adjacent, which is x, divided by hypotenuse, which is a. And the implication of this is that x is equal to a times the cosine of theta. When I use the sine theta is equal to y, which is opposite, divided by a. And the implication of this is that y is equal to the magnitude of the vector times the sine of theta. If I make x and y the subjects of the formulas in the respective expressions. And now the vector OP can be resolved in the form x along with the xi and then y j. And so x, that one is a times cosine of theta, that is now I, plus now the y, which is a, then sine of theta, and this one is j. So we have this one and that as it to be the components. A cos theta is the component of the vector OP along the horizontal, along the x-axis, while a sin theta is the component of the vector along the vertical axis. We call that resolving. You have a magnitude and a direction, and we are looking for the components. So you can work back and forth. You can, when you have the vector, you can get the magnitude and the direction. But when you have the magnitude and the direction, you can do what we call resolving to get the vector itself. So the vector is there. There we are. Now there is something I want you to know about resolving these forces. If I want to have, I can have the vector OR, which I can write as R, and then I have that the magnitude of R, I can call it R. like that. Now if I want to get the magnitude, if I want to get the component of r, the vector r, along with the x and along with the y, this is what I do. The component, this is something to know. The component of a vector along a given direction is got by getting the magnitude. You get the product of the magnitude of the vector and the cosine of the angle between the vector and the required direction. So if I want to resolve OR along with the x, I get r times cosine of theta. R x is equal to r times cosine of theta. I'm saying that this theta here is the angle which r makes with the x axis. That is when I'm resolving along the x direction. Now what about the y direction? There I have to consider this angle 90 minus theta, and still I say that y is equal to r cos of 90 minus theta. It is just a matter of getting, what are you doing? I want to resolve this along the x-axis. Get the magnitude of that and the cosine of this angle. What are you doing? I'm resolving this along the vertical. Get the magnitude of this vector times the cosine of the angle between the vector and the direction in equation. But when you look at this, when you work out this, cosine of 90 minus theta is the same as the sine of theta. That is what we have, because it is that cosine of 60 degrees the same as sine of 30 degrees. This one is the same as 90 minus 30. It's the same as 90 minus 30. So you see that cos of 90 minus 30, the same as the sine of 30 itself, is what I've written there. You can check this with the calculator. So there, it means that, by doing that, we have resolved. And the vector r can be written as the form xi plus yj, and x is r cos theta. Now this one is this one is I. Then for y we have r sine of theta j, which is still in concurrence with what we got in up there in the other two, the first case. It is coinciding with this. So that is what we do. We are going to use this and that. Shall use this one and this in the sum of in the example we're going to have. So example 1, they have given us 6 units as what we should do. Whatever you are resolving should be the hypotenuse. So they want to write this one in the form ai plus bj. So we can call this one, since b is along the vertical, that is b, that is a. So we have that I can say that a is equal to, you are resolving it along a, along the x. What are you resolving? The vector OP, which is 6 units. So you have 6 times the cosine of 30 degrees. Then b is equal to, b is like along the vertical. If I complete this one along that, the b is there, either here or there. So the angle, you are resolving it along the vertical. This angle is 60 degrees, 90 minus 30. So we have 6 cosine of 60 degrees. So this one is, first of all, this one is 3 root 3, while this one is 3. That means that the vector P is equal to, they said A, so this is 3 root 3 I plus 3 J. But I can also say that cosine of 30 is equal to adjacent, which is a over 6, opposite adjacent over hypotenuse, because OP is 6, and I have that a is equal to 6 cosine of 30, which shall still give me 3 root 3. Then I say that sine of 30, still sine of 30 is opposite, which is b, divided by 6, and I have that b is equal to 6 sine of 30 degrees, which will get me 3 still as before. And then I write the vector p like the way we have written it there. But b, this one we can do it two ways. Still can do it complete around here, and call this one b, then complete around there, and call this one a. It is either there or here. So we have this one is 50. We say that sine, if we use trigonometry, you see that the cos of 50 degrees is equal to adjacent, which is a, divided by hypotenuse, which is 7, such that a is equal to 7 cosine of 50 degrees, and this one is to get us 4.5. Is 4.5 just. Then sine of 50 degrees is equal to opposite, which is b, divided by 7, b is equal to 7 sine of 50 degrees, and this one gets us 5. Let's write it as 5.4, and the vector p now is equal to 4.5i plus 5.4j. This one is negative because the horizontal component, because that j is the end vector along the x-axis. So the component of this OP along with the component of OP along with the horizontal is towards the left. You can see it is moving towards the left, and from there towards the left we have negative along with the x, and towards the up there, towards up along the y, that one is positive. So the y component is positive, but the x component is negative because it is moving towards the left. Always take a note of that. I can take care of that by having this. When I want to resolve the value of the force OP along with the positive x-axis, I just get the 7. So I say that a is equal to 7 times the cosine of the angle between the intended direction and the vector. So this time the angle which we are dealing with is that one here. I'm resolving it along with this. So I have the vector, the magnitude of the vector times the cosine of the angle. You see, cosine of that angle, which is 180 minus 50. So I have the cosine of 130. That is cosine of 130, and here you get the value directly, negative 4.5, without even saying that. Now whether you know that the left will be negative, this one is giving it to you directly. Then b is you are resolving, b is the component along the vertical. So what you do, you get the angle, the direction intended is OY, this direction. What is the angle? The angle is here. It is here. It is 40. And so the component of this one along with that one can be got by getting 7 times cosine of 40 degrees. And there we shall have that b is equal to, it is still 5 0.4. Then I write out the values just like the way I've written them there. Actually we said the component of a vector along a particular direction can be got by getting the magnitude of the vector times the cosine of the angle between the vector and the intended direction. You are resolving 7 along the vertical. What is the angle between the line OP and the vertical? It is 40. Get cos of 40 times 7. That is the component along the vertical. What is the angle between the horizontal and the vector OP? It is 50. Get it is not 50 actually. It is we always refer to the positive x direction. So we shall have 180 minus 50, which is 30, and there we are.